Okay, so if you remember, we've been talking about arrays, which are a group of similar variables which all have the same type and which have systematically related names that involve special syntax using these brackets. So if we have an array A, I can refer to each of the elements in that array by indexing it starting at 0. So we have like A sub 0, turn this around. Okay, A sub 1. And we refer to these arrays or the elements in the arrays starting at 0 because we index by 0 because we are normal computer scientists, unlike MATLAB users. And then we have the length of the array, which is just known as a dot length, which is the number of array elements. And I believe there's a nice little picture, which I will copy down. So this is arrays as we have been talking about them in class thus far. So we have 6, 18, 9, and -10. So they're each stored within their little box in this filing cabinet. That's the reference that I use. And you refer to them by their index in the array. So we would say 8 is at index 1, or it is the first element of the array. We start with the 0th. So 6 would be the 0th element of this array. And then, of course, if we wanted to refer to the length of the array, the length of the array is its own separate built-in Java variable that Java gives us, which is just the length of the array. We can call it using a.length. Who can tell me a good example of when you would want to use a.length? Why do we even care about the length of the array? Yeah.
You're trying to use a for loop and you're trying to put an array.
Exactly. So if you need to loop through it, you don't know exactly how many elements are in the array. Well, you do. It's actually just stored in a.length. So, but this is the veil of ignorance you guys have been living under for the past semester. Not semester, like month. Now you know that reference types exist. Not everything is simply a primitive object type, and arrays are reference types. If you remember last week, we talked about reference types where the actual object value of a particular type might not be stored directly where that variable is stored in memory. Sometimes you might have a reference, which gives you a little map, which points directly to the object value. So arrays are reference types. They are not primitive. And so the name of the array is a reference to the entire collection of element variables and a.length. So not only do we have our reference type A, which we always represent using an equilateral triangle. This, we don't show it, but this will store some memory location in Java. Let's say, for example, that this is 33. And that reference location will point to the entirety of this array right here. So it's kind of like a big reference type. So the big thing, arrays are reference types. So now you should be able to predict what happens when you do the following: assign one array to another using equals. What will happen if I have this A and then I say B equals A? There's a special term for it. Does anybody remember the special term? We say that A and B are aliases. Thank you. I was about to say failing midterm too, but no, we got it. All right. So A and B in this case are aliases. So if we have B, instead of setting B equal to, say, the object value, instead, B and A simply point to the same thing. So we can draw it like this, where A and B are aliases, meaning that if we were to compare them, the reference values would be the exact same. So A and B both have reference values of 33. 33, of course, pointing to the location of that object value in memory. Does that make sense? Okay, what's going to happen when we pass an array as a parameter to a method? Is it going to be passed by reference or passed by value? Somebody raise your hand. Yes. Yes. So let's say we had a method called S method, which stands for Stevens method, and we passed in array as a distinguished formal parameter. When we call the S method, array is not going to be copied by the object value. Instead, we're going to be copying whatever this reference location is. So if we passed the array as a parameter to a method, and then we increased every single integer, let's say S method did that, it increased every single integer in the array by 1. After we got back out, all of those array values would be increased by 1 as well, because we are actually updating the object value of the array. This is different to, say, an integer, where if you pass something into a method, it's passed by value, and so after the method was done, the original value would remain the same. Same thing with returning from a method. Now, comparing two arrays for equality with equals equals. Somebody give me a case where this would return false. When you have two arrays and you're saying equals equals, give me an example where that would return false. Yeah.
They're like brushes. Values not the same.
Yeah, exactly. So if you have two arrays which are different, so let's say duplicate this picture, except call it B. When you're actually using equals equals, Java is comparing these object values. So if B was pointing to another array, which I'll refer to as this ellipses, that's going to be stored in, say, reference location 34 instead of 33. So Java is going to take those reference locations. Even if B is the exact same array, it's going to return false because the reference locations are not the same for both of them. Okay, now how we usually get around this when we're using reference types is using the dot equals method. However, when you're using the dot equals method with arrays, it just compares the reference values just as it would with equals equals. You might expect it to compare arrays element wise. So let's say we had an array B, which was the same exact thing with 6, 18, 9, and -10. You might expect that if you use dot equals, it would compare the elements element-wise and say, okay, is the first element the same, second element the same, third element the same, fourth element the same. But Java is actually not smart enough to do that. So it doesn't compare it like that. Fortunately, spot bugs will flag the use of equals and explain that it's equivalent to equals equals. So if you want to compare whether two arrays are exactly the same, you either have to implement your own equals method, which is quite difficult, or you can use a built-in method, which I'll talk about. So java.util, which is a very good package, which has a bunch of like utility stuff, has an arrays class, so java.util.arrays, and arrays has two methods, equals or deep equals, which compares the arrays or comparing arrays of arrays. Okay, yeah. The static method array.equals or arrays.deep equals. The difference between array.equals and arrays.deep equals is sometimes we've been talking about arrays mostly storing primitive types. But since arrays can store any type in Java, arrays can store arrays. These are called two-dimensional arrays. Arrays can also store arrays which store arrays, which are called three-dimensional arrays. And you keep going and keep going. Two-dimensional arrays are something we don't get into in this class, I don't think, but essentially it's just a normal array. Only at each index is a whole other array. So it's kind of like a grid. So you can have 1, 2, 3, 4, 5, so on and so on. So what deep equals will do is it will test to make sure that both every row is the same and every column is the same. Because how you index two-dimensional arrays is you have to use 2 instead of 1. But we won't get too deep into that. We won't get arrays.deep equals into that, if you will. Any questions on arrays as we've been talking about them? Yeah, so equals is the only one that you should be using. Deep equals is only if you're comparing arrays of arrays. Because I think if you just use equals, it will just test the first row. Deep equals is like a more thorough way of checking that. Okay, any other questions about that thus far? So what's the best practice? In industry, it's to avoid using them. It's okay in exercises intended to demonstrate like the basics of arrays, because arrays are a pretty fundamental thing. in Java and in most programming languages. And there's a lot of Java code in the wild that uses arrays and simple throwaway programs. And we use them a lot because it's very easy to just store 5 or 6 elements and then do something with them to illustrate a concept. But there are some alternatives. So there's lists and array lists. You can think of array lists as just dynamically sized arrays. So instead of being limited to the amount of elements that were in the array when you defined it, array lists can be dynamic in their size. And then in OSU CSE, because we like to be different, we use sequence, which I don't think we talk about for a bit. Okay. Any questions on arrays and array value types? Going once, going twice, yes.
My favorite avoided industry software, industry practice stuff.
Mostly because they're a lot of the times, so arrays, because you can only store a certain number of values in them, and you have to know exactly how many values you're storing in them before you define it, it's very, very useless in, say, like industry where, let's just say we wanted to store the usernames for everybody who's signing up for our website. How many people are going to sign up? We have no idea. So using an array is useless. We would rather use like an array list or somewhere that something that is like dynamically updating. Essentially, it comes down to like the real world is not cut and dry because everything we do in this class is very like, it's like how in physics you make assumptions that gravity is just 10 or how there's no wind resistance, but in the real world, that's not true at all. In Java, we make the assumption that we're always going to know exactly how many elements we need to use or exactly how many people are going to be inputting into the file or something like that. Whereas in the real world, that's not the case at all. Does that make sense?
Yeah. So like, can lists do that or like?
Yeah, so lists are dynamically updated arrays. So let's say I had a list that was empty. I can call list.add and it will simply add the element and suddenly the length will be 1 instead of 0. And you can keep doing that over and over again. Yeah.
For like the array dot equals,
Mhm.
that'll work for primitive types.
Arrays dot equals works for pretty much every type other than array, or sorry. Are you asking about arrays dot equals or just
What?
dot equals in general?
Arrays dot equals, like when you compare them back. That only works for new types, or like if you had like an array of like natural numbers, would it be able to see if they were equal?
That's a great question. I would say that arrays dot equals should work. I would actually have to check that and get back to you.
Okay.
I'm gonna write it. I'm gonna write a little note. Can you Slack DM me and remind me? Because I'm actually interested in like
Okay.
knowing the answer to that.
If I remember.
Just do it right now. Don't pay attention to me. Okay. Any other questions on arrays? Yeah.
The array list in this class.
No, I don't think so. We use sequence, which is kind of like similar. I think you get into it in software too. Yeah, a lot of the fun stuff gets, it's like what's the word? Guarded? I don't know. Paywalled behind software too. You have to pay tuition again. Yeah.
So what's the purpose of using array?
Yeah, so it's because a lot of legacy code uses arrays, so like in industry, so that's one of the reasons. And then it's also very good and it's simple in terms of like going through examples. So if I wanted to make an example where I was demonstrating what the dot increment method was and how it worked on like multiple different natural numbers, it would be kind of pedantic to just make an entire array list and all this other complicated jumbo when arrays are just a very simple way to explain it. Plus, arrays are also good because they have one of the big things about arrays is they have instantaneous access time. We don't talk about like efficiency in this class, but foundations 1 and 2 do, where the amount of time it takes for you to access an element within an array is constant, or it's called O of 1. So if I have an array and I want to know what the value at any point in that array is, I can do it instantaneously. Whereas if I had an array list or I have a stack, in order to ask, hey, what's the value at the 18th or the 19th element? Or if I wanted to find something, it would take a lot longer. So it has some like efficiency benefits to it. Okay. We're having a great discussion on arrays, but does anybody have any final closing comments? Okay, awesome sauce. Now we're going to move into contracts. We're switching it up a little bit. You guys are going to take a quick detour into law practice here today. So we've been talking about contracts, which are essentially an agreement between the client and the implementer that describe how the method ought to work. So in terms of the client, who can tell me what the client is responsible for? There is a certain clause that the client is responsible for.
Requires clause.
Yes. So the client is, can you explain what the requires clause is, or what it requires of the client?
Well, it's the precondition, so like the client has to do something that the method needs before they start, before the method starts running.
Exactly. So the client is in charge of satisfying the precondition or the requires clause. And as long as that is satisfied, who can tell me the other side of the equation?
Insurance.
Exactly. The insurers are the post condition. So there's this kind of two-way handshake between the client and the implementer, where the client is kind of trusting that the implementer wrote the method correctly and didn't mess up. And the implementer is kind of trusting that the client is going to call the method with normal arguments and not be weird. Yeah.
So sure, and what is there two?
Requires and ensure. Yeah. Requires is relating to the client. He's required to, I'll just write it down. So you have your client who calls the method, who's in charge of making sure that the requires clause is fulfilled. And that is what's known as the preconditions. They should all seem pretty familiar. And then you have the implementer who implements the method, is in charge of making sure that the ensures clause is correct before it returns value, and it's in charge of making sure the post conditions are satisfied. Now, we've only been talking about the sort of requires and ensures clause thus far, but we're going to get into a little bit more today. More so, we're going to be talking about parameter modes. Parameter modes are ways that you can describe the distinguished formal parameters of your methods in order to describe or sort of hint at what the behavior of the method is going to be. We'll get into that. So parameter names in requires and ensures clause always stand for the object values, never the reference values of the corresponding arguments to a method call. So if we have a static method and we're passing in a natural number A, when we're talking about that natural number A in the contract, we're never referring to, oh yeah, the reference location 33. We're always going to be talking about the actual object value. So if we have a natural number A, the contract is always going to be referring to this 34 value, the actual value of the natural number. And you always can assume that reference type arguments are always non-null. So you're never going to have an A which is just pointing towards nothing. So, and this is something local to OSU CSE. Okay, so there are four what are called parameter modes, each of which indicates a possible way that a method might change the value of the corresponding argument. So each argument in your method header, so let's say you have 5, each of them is going to have a parameter mode. It's going to be something that describes how that parameter might change throughout the course of the code. They concisely summarize which arguments might have their values modified by a call. And they're also used to make the requires and ensures clause shorter, because you can imagine if we have 20 different variables, we don't want to have to write that we're requiring or we're ensuring that A is going to be equal to A plus 1, and then B is going to be equal to B plus 2, so on and so forth. So let's get into, modes are listed for formal parameters, including this, but actually apply to their corresponding arguments for a call, including the receiver. So I'm going to throw up an example of a method. We'll call it my method. let's say it takes in an integer A and a string B. When we're talking about the contract, the requires and ensures clause are always going to be talking about A, but it's kind of a misnomer because what we're actually referring to is, ooh, my bad, is when we call that method and we pass in, say we have an integer C and a string D, we're actually, sorry, I don't know if you can see that now. We're actually referring to the arguments that are passed in. So even though we might be talking about integer A and string B in the contract, those are just placeholders for when we actually call the method and we are passing in arguments. And the same thing goes for instance methods, which are methods that are called, again, on an actual object. We might refer to this as the object value. Say the add method, this dot add, we might refer to as in the contract, you might be referring to this, but again, this is just a misnomer for whatever object you're calling the add method on, because we don't know what the name of the object is going to be yet. Okay. So first one of your little what are they called? Parameter modes that we're going to talk about is restores mode. This is the simplest, and essentially it just says that it is going to be the same as the incoming value. So this is a default parameter mode. So any parameter that is not described in one of the other three ways is going to be a restores mode parameter. So this is equivalent to adding that line over there. Does anybody remember how we would write or how we would read that line of contract out in plain English from last week? Yeah. Yeah, so X is going to equal the old value of X. So restores mode essentially means that the old value of X will always be, or the new value of X will always be equal to the old value of X. And an old source mode should not be in restores clause. Yeah, so this is the most simple of the three. Of the four. The next one we have is a clears mode. So we've been talking about how primitive types, and especially if we're talking about reference types, always have a default value. So for natural numbers, it's 0. For integers, it's 0. For strings, it's the blank string. A clears mode parameter means that the parameter will be cleared back to an initial value. It's the same as saying, and X will equal an initial value for its type. So if we have a method contract and integer A is of clears mode, then after the method is concluded, we can ensure that A is going to be equal to 0, or a string is going to be equal to the blank string, or a natural number is going to be equal to 0. Right. Oh, yes. So it's possible that there is. So for reference types, it will reset it to the value of the no argument constructor. So if you remember when we talked about XML trees, that's a bad example. We talked about natural numbers. If you didn't provide a number or a string or another natural number in the argument, it was a no argument constructor, and it just set the value of the natural number equal to 0. Again, that's what it gets reset back to. So here's an example from the transfer from method, which clears n. So if we're just looking at this method contract and we have no idea how transfer from is implemented, we can be sure that after the transfer from method is called, n will be reset back down to an initial value, which is 0. Okay, the third one is a replaces mode parameter. So this essentially describes that the value might be changed from its incoming value. So if we have a replaces mode, string B, the resulting value of B after the method call might be different than the incoming value. So here's an example. We have copy from, copies n into this. Remember, this is the placeholder for the instance method or the object that we're calling copy from on. And we're saying that this replaces this, or n replaces this. All good so far? Yeah. Yeah. replaces mode parameter X should not appear in the requires clause. X requires clause. I believe it's because if we're talking about a method, because we are replacing X or because we might change X, we can't add any stipulations onto what X is going to be before it enters the method. And the same reason for the old value of X should not appear in the ensures clause, because the old value of X is going to be irrelevant after the method call because it's going to be replaced. Okay, and then the final one is updates. Wait. Okay, difference between replaces and updates is different. Method value. Upon return from a method call, a replaces mode parameter has a value that might be changed from its incoming value, but the method's behavior does not depend on its incoming value. Okay, that's the difference, is that you can't use the new value in the requires clause and you can't use the old value in the ensures clause because the method behavior should not depend on that incoming value. So if we're looking at the example of copy from the replaces mode parameter, this the implementation of copy from should not depend on what the value of the natural number is that we're copying from. So it shouldn't matter what the old value of this or the natural number that we're calling copy from on is, because we're simply copying that new value of the natural number into this. Does that make sense? Cool. And then updates mode, upon returning from a method call, an updates mode parameter has a value that might be changed from its incoming value, and the method's behavior does depend on its incoming value. So updates mode and replaces mode describe the same thing that's happening. The only difference is that replaces mode, that parameter is not going to have an impact on the method body or the way that the method is constructed, and updates mode might. Yes. So in other words, updates mode and replaces indicate that the parameter can change its value. Notice that in all of these, we're saying that it can change the value because it does not have to. We're simply saying that it might. The difference is that the former, the behavior of the method is independent of the incoming value, while for the latter, it is not. So with replaces mode, whatever is going on in the method body, the value of the replaces mode parameter should not have an impact on that, whereas updates mode, it can. Okay, any questions on those four method, on those parameter methods that we have so far? Yeah.
Replace, not have like any actual update values.
No, the behavior of the method is independent of the incoming value, whereas with updates mode, it is not.
Oh, so that's is that what it's of places?
Yeah. Yes. Any other questions? Awesome. So an example of an updates mode parameter is add. So if we're looking at add, the ensures clause is that the old value of this plus n equals the new value of this. Because the value of this or the method body depends on the old value of this, we use an updates parameter because this is going to be updated essentially. So what the value of this is important for the implementation of the add method. Okay. And then again, this is what we talked about before, where when we're talking about these parameters, we're talking about the object values of these parameters, not the reference values of these parameters. We don't care about where they're stored in memory. What we actually care about is the actual object of the corresponding argument. Okay. So as an example, in the copy from method, we copy n to this. We have a replaces mode parameter, which is this, because again, we don't care what the value of this is before we call copy from. We're simply saying that we're going to copy the value of n into this. So the value of this is irrelevant. And in our ensures clause, we ensure that the new value of this is going to be equal to n. So contracts are very good because without even seeing any piece of Java code, you could look at a contract and tell me exactly what the method does. So this might be a question on like a midterm or a final where they don't give you the exact implementation of a method body, but they ask you, what does this method do based on the contract? And if you get very good at reading contracts, you can do this pretty effectively. Yeah. Not in software one, I don't believe. When you get to software two, you get into like some meaty contracts. But a question might be given the contract for copy from, what does the method do? Or given the contract for copy from, and then it might give you like a call to copy from, what are the values of n and x, which are two natural numbers, going to be after the call? And you'd have to understand what the requires and ensures and replaces clause are. Okay, so again, just a tracing table here, m.copy from. You'll see that after the call has been made, the old value of m, 143, was essentially irrelevant because we don't use it anymore, and that's why we have it as a replaces clause. And this is just showing you that aliases are not being had. So instead of, say, what you might think or what your premonition might be about how to set m and k equal to each other beforehand, which is just to set m equal to k, that would not be good because it would make an alias between m and k, which are both pointing towards the object value of 70. M.copy from, however, copies the object value of k into m. Okay, what line of code would result? Oh, okay, yeah. So the line of code that would result in that outcome is just setting m equal to k, because as you all know from the lab, if you went on Friday, if you set m and k equal to each other, you're setting the reference values equal to each other, and they're both pointing towards the same object. Okay, so another thing we talk about is any reference variable may be given the special value null, meaning that it does not refer to any object at all. So we describe this with a triangle, which is kind of just pointing sadly into the ground. And null essentially means it's not pointing towards an object at all. So instead of an arrow, we have this little transit symbol, I guess. It is not unusual to find null references in Java code. It is a very good idea to not use nulls. I think the best practices that we describe is to not use null values in your program, because the most common cause of crashes is null pointer exception, which means the code attempted to follow a null reference to which it refers. So if we're going back to our map example, you can imagine a null reference as you have a map where it just does not point anywhere. So Java will get to your object value. Let's say this is called C. And let's say you wanted to print C, so you called print C. Java would go to C, and it would have a map which pointed absolutely nowhere. Java gets very angry and throws this thing called a null pointer exception at you, because there is a null pointer. And then here's a quote from Sir C.A.R. Hoare, 2009. And he says he calls it his billion-dollar mistake. It was the invention of the null reference in 1965. I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 4 years. So there's the inventor of the null reference, basically calling it like a dog shit invention, which... So yeah, don't use null references. Somebody look up what Sir CAR stands for. I'm kind of intrigued. And then raise your hand when you look it up, because what a dope ass name.
Charles Anthony Richard.
Okay.
Given by Tony.
Okay, yeah, I was about to say, if you went by anything else, it'd be a little bit awkward. Okay, what a dope name. Okay. OSU CSC components contracts stipulate that no argument to any method may have a null reference. Hence, there can be no question about a reference type parameter. So our best practice is to just not use null values, because they are, I mean, listen to Sir Charles what?
Anthony Richards.
Charles Anthony Richards Hoare 2009 says don't use null references. And if he says so, then yeah. And if you want to read his book, wait. All right. Everyone read this article. That's your homework. Okay. Any questions on contracts? thus far. Yes. Yeah. I'm gonna add a bonus question called "What is Sir Charles?" Wait, sorry. Wait, what is it?
Charles Andrew.
Yeah, what does Sir Car stand for? And it'll be worth 0 points, but if you get it wrong, I'm gonna be very angry. Okay.
Can
What was that?
you make it a bonus point?
I don't think I'm legally allowed to do that. I think if I even talk about bonus points, like there's a sniper on me trained at all times.
To be fair, I heard about somebody from my other one.
Yeah, got bonus points. Yeah. I have a friend who's taking software 1 right now. And I was like, he's like, I got my exam back. The question about like Groot and Thanos was weird. And I was like, what are you talking about? And this teacher made her own exam. I didn't even know that was an option.
Actually, yeah, I heard about somebody. I heard one of my friends told me that their teacher made their own exam for the course, and I was like,
Yeah, that's messed up. I would have done that. My exam would have been sick.
oh
Okay.
my God, you could have totally made a question about all the memes.
Dude, my exam would have been hilarious. Would have been like if Baby Gronk calls the dot admin.
Or about all the Pokemon references.
Yeah, it would have been it would have just been all like outlines of the original 151 Pokemon. And you have to name all of them.
Maybe
Sorry, that's
maybe-
good. That's an
maybe-
instance method right there. Where Baby Gronk is the object. Okay, guys, we have to lock in here. Repeated arguments. So alias references for mutable types can cause trouble. So it's important to know where aliases might arise. One way is the simple assignment of one reference variable to another. However, this is not the only source of aliasing. So if you have 2 variables, S and K, and you set them equal to each other, that's one version of aliasing if they're reference types. However, there are other sources of aliasing as well that you have to be cognizant of. Big word there. Okay. Because a formal parameter of a reference type is initialized by copying the corresponding argument's reference value, parameter passing is another source of aliasing. What does this mean? So if we have a method where, let's say the add method took in 2 natural numbers, natural number A and natural number B. When you pass in A and B into the function, you're actually passing in the reference value as opposed to the object value. So this entire slide deck essentially asks the question of what happens if you have a natural number X and you pass it into both the A and B slot. We'll find out. So consider this method. I want you guys to take 30 seconds here, read the contract, and then can somebody tell me what the result of this method will be? What will be the result of foo after it is called? Let's give you an example. Let's say X is equal to 99 and Y is equal to 100. What are the object values of X and Y going to be after this? Yeah. Perfect. Yeah. So if you called this on your X and Y, the ensures clause states that the new value of X is going to equal the old value of X plus 1, and the new value of Y is going to equal the old value of Y plus 2. So if we're looking at natural numbers, does somebody want to give me an example of how you might implement this method? What methods that are relating to natural numbers could you use? Yeah, so that's one way. You could just call increment on X and then increment twice on Y. What's another way that you could do it? Yeah, so you could add X equals X dot add new natural number 1, Y dot add new natural number 1. The point is that there are many ways to implement this. Okay, so we just did this exercise. As you can see, when you have 2 natural numbers and you call it the way it's expected to, this is the picture that I think I drew on some of your guys's papers. But essentially, you pass them in, and X and Y get aliased to the object value of 10 and 319. And then after the method call is done, A is equal to 11 and B is equal to 321. So we've added 1 to A and we've added 2 to B. And then the call is done. So that's how it is normally supposed to work. However, aliases are created, but since the method body for foo only has access to the variables x and y, i.e. the variables used as arguments in the client code, A and B are not in scope while the body of foo is executing, these aliases cause no trouble. So essentially, because the method foo does not have access to A and B because they're not in scope of the method, there's no need to worry here. However, if we have simply one natural number and we call foo AA, now we are passing in A as both the first parameter and the second parameter. So what is going to happen here? Does anybody have any predictions as to what the value of A is going to be after this call? Yeah. Why do you say that? Exactly. So here's the picture. Let's walk through the example. We have a new natural number A. We call foo. And now we have that both x and y are pointing towards the object value of 10. So after the method is concluded, where we're saying that x is going to equal x plus 1 and y is going to equal y plus 2, the value gets set equal to 13. So can we really be sure the resulting value is 13? Surprisingly, no. And the reason that this is because the contract, where's the contract at? Here, the contract for foo ensures that x is going to equal x plus 1 and y is going to equal y plus 2. But if you're passing in the same value, this is impossible. So you can't be sure. There's no outcome that expected that would fulfill the insurers clause of the method contract. What did I skip? Oh yeah, so aliases are created between two variables that are in scope while the method body for foo is executing, i.e. x and y, and these variables cause trouble. So whose fault is this? The implementer or the client? Anybody have any guess? Anyone want to throw somebody under the bus? Yeah. Why is it the implementer's fault?
He didn't put the clause that they would have to.
Yeah, you could say that. So the implementer could have included that as well. That's actually probably a smarter way to do it. The actual answer is that nobody's at fault. You're just not supposed to pass into two variables. So it depends on whether or not you're trusting the people calling your methods to not be idiots, which you should never do. But that's what Java wants you to do. It trusts you to just not be an idiot and pass in double parameters. But the smart way to do it would probably be the implementer, ensuring that the two variables can be equal or not equal. Okay, so it is asking the question, in an ideal world, could we have the fact that A is both equal to A plus 1 and A is both equal to A plus 2? The answer is no. That is too perfect of a utopia. It would be impossible for any implementation of foo to produce the outcome, supposedly ensuring the insurers clause in the contract. So that's the trouble with repeated arguments. This is a problem in every programming language. So the solution, hold on. Oh, wait, I guess we got to go over this. So when we're talking about reference values or instance methods, where this takes the name of the formal parameter, there's also a repeated argument if you pass in itself as an argument. So natural number add takes in a natural number, but it's also called on a natural number. So if you call n.add n, that also creates an alias to this, which can cause the same problems. This is called double n. You might expect from using informal reasoning and wishful naming to predict the outcome. The reason that this is a bad idea is because the contract of add, I looked it up today. Essentially, it has something to do with the fact that I think the parameter modes of add do not allow for this to happen. But it's irrelevant because all 27 slides have led to this moment here, which is don't use double parameters. That's it. So if you take away anything from this, it's don't use repeated parameters. Are there any questions on repeated parameters? They're bad because they create aliases between the same variable, and you can never predict the outcome of a contract. Check style and spot bugs do not warn you about this. However, it is pretty, I don't know, it'd be very difficult to accidentally pass the same argument in twice. Any questions on that? Yeah.
Well, never.
of mutable reference. So don't use repeated parameters. So
Don't just,
yeah, so don't call foo AA
okay.
essentially. Yeah.
Does it matter if they're immutable things?
If they're immutable, I think you're okay to pass them. Because they can't change anyways. And then also for primitive types, you could technically pass the same thing. But when we're talking about mutable reference types, so remember, mutable means that they can be changed throughout the method body. You don't want to give the implementer the power, I guess, to fuck around with your variables. So just do not pass in arguments twice. Does that make sense? Okay. Sick. That's all I have if there are no other questions. Have a good rest of your day. Hopefully I will see you tomorrow. If I don't die.
Thank you so much.
Yeah, have a good one.
I think you are, because I can.
Yeah. It's up there on the screen.
But I complete the lab, I missed one.
I would say it's one of the more important ones because it goes over like reference types versus, and it has you trace through them. I would say it's pretty important.
Okay.
If you have any questions, you can begin.
Yeah.
First call it.
Yeah.
Yeah, no, it's, I saw that earlier, it was on.
Yeah, I mean, I did sleep late on Sunday. Yeah, so I finished today's pre, it was just reading, we're just reading. I finished tomorrow's pre. I only got to like most of the pages.